Okay, Ellie, we're going to go through this. I've got some inspirational music playing in the background. It's from I guess a CrossFit workout where you can, anyway, it's good pumping music, which is perfect for math, isn't it? And so, all right, we'll see if this helps aid your education. All right, so originally we're given the expression that you sent me, and we're told that this differential equation right here has to go through this point, which is the square root of pi divided by 3, all that pi divided by 3 all being under the square root, and the y value is going to be equal to 1. And so right away, recall that the derivative of arctan of z is just equal to 1 divided by the quantity 1 plus z squared. And that seems important to me because up here, you'll note that we ended up with 1 divided by the quantity 1 plus y squared, so the form seems similar, so just kind of keep that in the back of your head. All right, so now we go ahead and separate our variables, which is a common approach for a first order differential equation where you just have like the first derivative. But when you take your differential equations class, you'll learn their higher derivatives and different approaches for those. So go ahead, separate your variables. You get dy divided by 1 plus y squared equal to x times dx. That should look really similar to you and allows you to focus on the pumping beat exercise music in the background as you do something without having to think very hard about it. And so you get the arctan of y is equal to x squared divided by 2, and then you have the constant plus of integration right here. And that takes you to the next task, which is going to be to determine the value for c. But first, I skipped one step, which is that to isolate the y, you have to take the tangent of both sides. Arctan is just going to be undone by its inverse function, which is tan. And that gives you this expression right here and right here. So there's your general solution. Now we're going to solve for the constant c, and that's where the initial condition that you were told up here that it needs to go through that point. And so all we're going to do is take this differential equation and plug in the x and y values for that. And so that's what gives you this line right here, which is as I've written. And we're going to solve for the value of c. And that brings us to the next line. I'm going to square the radical pi over 3. That just undoes each other, and you're going to be left with pi over 3 divided by 2. Now you'll remember the double rainbow formula, or whatever we called it, and that essentially allowed us to keep track when we have a complex fraction or a compound fraction. So the 2 and the 3 are going to be multiplied together to give you your new denominator, and the 1 and the pi are going to be multiplied together. And so, you can think about one rainbow being right here, and then the other rainbow being right here. So that gives you this expression. And now you're left with 1 is equal to tan of pi over 6 plus constant. So I note up here, though, on the side, look at this note, okay? Since I know that if I have the tangent of some angle and it's equal to 1, I know that the angle has to be either pi over 4 radians or 45 degrees. And that is for all angles between 0 and pi, or 0 and 180 degrees. And so that gives me this expression right here. And so the reason why what I just told you about the tan of 45 degrees is important, because you're going to write this side of the equation, which was your previous right-hand side, you're going to set it equal to tan of pi over 4. And whenever you have two trig functions, two of the same trig functions that are equal to each other, then you can just equate the arguments. And when I say the argument, that's like what's inside the tan function, or the argument of an exponential. Like if you have e to the x, the argument is the x. I'm not exactly sure where that kind of terminology comes from, but when I say argument, that's what I mean. And so we're going to set pi over 6 plus c, we're going to set that equal to pi over 4. Okay, and that's where we get this line right here. And we're just going to solve for c. And c ends up being equal to pi over 12. And so, therefore, that's what the 3 dots are for right here. Therefore, your solution to your differential equation, which we were originally given up here, is going to be equal to y is equal to tan of x squared divided by 2 plus pi over 12. And for extra credit, because I know that you're pumped up with this exercise music, is to actually verify that this differential equation is correct. I'm going to give you the y value right here, and you can figure out its derivative, and you're going to have to do the chain rule to do that. But if you substitute it in here, you should see that this side is just equal to x using this y function that we developed down here. Good luck.